Hello everyone, welcome to Jack Talk. Today, let's move on to discuss something on binary system. This is the third session of that topic. Session 1, we discussed on some very important principle because we do need some machine to calculate for us first. I like to speak, but we do need the reliability. That's why we pick the binary system instead of decimal system, right? Session 2, I explain you have to agree one fact first. That means we still can count by using binary system as we use decimal system as usual. Right? But of course, we don't feel comfortable with it because we don't get used with numbers with only 0 and 1, right? We like to see the decimal system. That's we need a so-called AD and DA conversion. Okay? We input analog decimal system. Let the computer process it in binary system because of reliability. Then translate, convert back to decimal system for display. And now it's fair. We are comfortable. Okay. Now today, the third session, I'd like you guys to agree with the fact 2. The fact 2 is we like the numbers to represent some other thing. What do I mean by some other thing? Like the element of our communication, like the letters of a language, like the Western language or English, we have 26 letters. Then we have lots of symbols, okay, even a happy face, whatever, enough to communicate each other. That's the first thing we like to do, okay, by computer. So way back to 40 years ago, 50 years ago, and people just like something, a machine. We replaced the mechanical typewriter. I don't know how many people use even, saw the mechanical typewriter. Mechanical typewriter is simple because we have only 26 letters in English, capital letters, and another 26, and then the calculation, symbols, addition, subtract, all those things, and some other, symbols. So maybe just like a couple hundred, maybe a little more than a couple hundred would be enough, right? So let's keep, something on decimal system first. That's easy to understand. And then pass over the idea and transfer the idea to a binary system. Okay? Let's start from decimal system first. For instance, we have 3 digits from all 0, 001, 002, 003. Remember, I said decimal system. All the way up to 999. We call that 3-digit numeral system in decimal. Right? Okay. Now, we can assign a certain number to mean something. A very good example is just like the combination lock. Okay? We use number. We turn the wheels, the little wheels, and then line up with a certain number. That means the lock can be opened. Otherwise, all the rest still keep locking. Right? So, for instance, we say 168, that's open. So that means a certain number means something, means open then. In other words, that means we could use number to represent something meaningful, right? That's good, because we do need number for processing. We do need binary number for processing, even though that's under text, language. Okay, we use numbers to represent all the elements of a human, communication. Now, I said if go further, we say a number 65 in decimal system represents the letter capital A in English. Can I? Yes, why not? I have agreement with you. Whenever I'm going to tell you letter A, capital letter A, instead of tell you A, I just say the number 065. That will make sense to you, right? And then you can translate from 065 back to the letter A. Computer does the same thing. Okay? So now let's take a look at that. If decimal system way back to the first session, we said that's not reliable. Okay? That's another story. Right now, I just like you guys agree with one fact first. We could use numbers to represent something meaningful. Typically, essentially, is the letters, the element of human language, human communication. Agree? Okay, good. Now let's move on to another system, binary system. How many, okay, before I say that, how many numbers here from here to here? 1,000, right? 30 still number, right? Okay. So that means we could assign 1 up to 1,000 things, 1,000 meaningful things to that 1,000 number. Okay, the maximum is 1,000. Otherwise, you have moved up to 4th digit. Now let's take a look at that binary system. The first generation of the computer, especially on the PC, right? Way back to the 1978, that's Apple II, Apple IIe, and then 1980, IBM announced the IBM PC, the first generation of the computer, personal computer. So there's a so-called 8-bit computer. What's 8 bits? 1 bit, that means 1 digit with either 0 or 1. 8-bit, that means 8 digits in binary system. Okay, let's put 1, 2, 3, 4, 5, 6, 7, 8. 8, 0. Okay, you may laugh. No matter how many 0, still 0, right? But that's the beginning. Because the computing is always start from 0. 0 is the first one. Remember that. Okay? Now, the second one, 1. Right? Then the third one, 2. No. I'm not going to use a decimal system. So that means this 1 plus 1, we have to move up, that means 1, 0. Right? That means 2 in decimal system. But in binary system is 6 zeros and then 1 0. That will make sense to computer. Okay? Not make sense to you or me, you and me, right? It doesn't really matter. We like the computer do it, right? We like the computer handle it. Now, let's move on 1 1, right? and then 100, right? Okay, I'm not going to all the way down, waste time. Okay, all the way up to the maximum is what? Is all 1. 1, 2, 3, 4, 5, 6, 7, 8. All 1. Something like all 999, right? Expired. The maximum number by using 8 bits. 1 digit is 1 bit. Okay. Now, I got a question for you. How many numbers from here to here? Just like I said, 3 digit in decimal system is up to 1000. But if 8 bits of the binary system, what's the maximum number? I got you? Okay. Too difficult. Now, let's do this way. Change the simple thing into quite complicated. Got the idea and then apply the idea to the new system. Okay. Now here we call that this digit is what? Okay, go back to high school. Okay. This digit is 10, 0, 10, 1, 10, 2, right? So if 999 plus 1 equal to 1000, that means this digit is what? Is 10 to 3 times cube. Right? Agree. So that means in order to calculate how many numbers within 3 digits, we use 10 to 3. And then we got a result is 1000. We use the same way and then apply to the binary system. So the binary system is what? Because the 10 base is decimal, right? Okay, let's move on. This part, binary system. This side, decimal system. Decimal system, I use 3 digits as example. The first digit is 10 to 0, second digit 10 to 1, third digit 10 to 2. It starts from all zeros, 0, 0, 0, all the way up to 999. Just like what I said, I like to know how many numbers are available for 3 digits in decimal system. All 0 is still a number, right? So all 0 as a number plus 999, I got 1000. 1000 then we 10 to 3. That's an easy way to calculate how many numbers are available here. Okay, we take this idea, apply to here. Binary system, that means use 2 as the base. The first digit is 2 to 0, 2 to 1, 2 to 3, 2 to 2, 2 to 3, 2 to 4, 2 to 5, 2 to 6, 2 to 7. Okay, so now I like to know from all 0 to all 1s how many numbers available. That's important because we use one number. We will assign one number to represent one letter in English. And also some other symbols, that kind of things. Okay, now put this all 0 as one number and add it together. Eight zeros and then move to 1 here. That means what? 9 digits. 9 digits, that means beyond 2 to 7. I got 2 to 8. 2 to 8 is important because the first generation of the PC, they use 8 bits of binary system because we have 2 to 8. 2 to 8 means 256, right? Try it, count it. 1, 2, 4, 8, 16, 32, 64, 128, then move to 256. We have 256 numbers available in binary system for 8 bits. And then we have 256 letters in language symbols, that kind of things to assign to. Then we can let the computer do it. Instead of tell the computer letter A, capital letter A in English, you just let the computer know 65. 65 means 0, 1, followed by 5, 0, and then 1. And this one represents 64 in decimal system. And this is still 1, right? 1 is still 1, no matter what kind of system. So 64 plus 1, that means 65. And 65, that means letter A, because that's our assignment. So inside the computer, they use that kind of things. For instance, we punch the keyboard, we punch the capital letter A, Shift A, and then the keyboard will go through the keyboard controller, convert that your physical action into that kind of number, 0, 1, 5, 0, and 1, and then process that. Finally, if the computer wants to display the letter A on the monitor, they will use the so-called digital to analog conversion. That's easy. Okay? That's how the computer does. Okay, that's a fact 2. Means what? I like you guys agree with. That means we could use number, no matter what kind of number, to represent something meaningful. Typically, we like the binary system, numbers, to represent letters in human language, symbols, that kind of things. And go further, let the computer do no matter what kind of things we like the computer to do it for us. Okay? Now, I stop here. Let's move on next section. Thank you for watching. See you next time.